Good morning, everyone. So after some break, we are starting to stream again. Let me know if anybody's here at all. And happy 8th of March to all the women who came to this stream. Okay, obviously nobody is here because everybody forgot that I'm streaming today. That doesn't really matter. Gonna stream some cool stuff today. This is me in Hollywood. All right. Okay, so today we're gonna break down this cool effect that I've seen on some of the websites. Exactly this one. And we're gonna be drinking some wine too. So you can see this cool math curve right there. And let's try to break it down. How to do this kind of geometric surfaces, this kind of effects in real time, and that it have still 60 FPS there. Let's try to do that. Okay. So first of all, let's start by creating some 3JS template, as I always do, and let's call it surface. Some surface. I'm gonna take the code. JS. Can open it up in a Sublime. Honestly, if anybody's in there, can anybody see me? Oh, I somehow don't see the chat. Sorry, guys. I don't know why it just didn't open up for me. So, morning, everyone. Sure. Oh, yeah, that was a fucked up title. It's not 1602. It's obviously 8th of March, but the date, the counting down date was the right one. Might have messed up with the guys, but you know, I'm streaming anyway. So good morning, everyone, again. So I'm gonna try to do the surface today, and also there was a kind of a dispute in Twitter lately about like, was somebody stealing from this tweet from Misaki Nakano, and then there was this award-winning website, Alessandra Zanghi, and I'm gonna try to answer that question, for me at least, if they have something in common. Okay, by doing exactly that animation today, and maybe experimenting a bit. So let's go ahead. I'm gonna create the usual template here. JS. Let's see. So we should probably see the right surface now. Parcel index HTML, and let's see. Hello, everybody. It's not good to make breaks in streaming. Everybody keep forgetting that you're gonna be online again on Sunday. No idea, but it's gonna be quite fun and cool. Morning. So we're kind of running the template for now. Let's wait until you see the red square. It's a nice guess. It might have been done with the raycasting, but who knows? Gotta wait a bit. Let's see. Alrighty, so we have the red surface now. Probably it's not red anymore because I replaced the red color with the UV color, so it should be red. Yeah, gotcha. So how do we go about creating those surfaces? One thing is to just download some model from the website and just load it, the file, and see it in the web page. But that wouldn't get us this weird animation stuff, like when you scroll, it keeps morphing into some other shapes, and it's cool and it's real time. So it wouldn't get us there. The next thing you could do the surface. You could change each position of the vertex with some parameter, with some function, with some displacement function. And let's try to do that. So we have this plane, whatever, geometry. We have plane geometry and with the material. What we could do, we could see what's inside that geometry, this geometry. Let's see. So this display is not a function. What? Okay, I just messed up with my template a bit. Been changing some time. Okay. Yes, geometry, cancel lock. We should probably see the geometry. So there we go. Geometry, what's inside of there? We have a vertices array in the geometry. And it's just 4 of them because why? Because it's a simple geometry which is 1 by 1. What we could do is this, and let's preview it. So it's more detailed example of the geometry right now, and we probably should see a lot more vertices there, which is yeah, like 121 now, because it's 11 squared. Alrighty, so what we could do next, we could change position of each of those vertices. So let's try to do that. We have this geometry, and inside of my loop, I can just do this. This geometry vertices for each vertex. I could do something like the z equals 0.5 multiplied by math sine vy, and then we always need to set the geometry vertices needs update true. I think it's right? 3js vertices needs update. Yeah, it's geometry vertices need update true. You always need to set this attribute if you're changing something inside the geometry, like normals, UVs, targets, etc. So let's see what we're gonna get now. Well, not much this moment, for whatever reason. Maybe I should multiply this by 50 or something. Yeah, because the wave was too big and it was too plain to see. So we could change the vertices like that. And by that I mean, like, we could come up with more complicated formulas for this one and do something weird. Like in the beginning it was just a plane, right? So each of the vertices has the x and y position. The z is always 0, I think, right? Because the plane lies in this z plane. But x and y are 2 parameters. So with those 2 parameters, we could actually introduce some other, geometric surfaces with those, right? So first of all, I would like to make a sphere. Sphere formula, sphere parametric creation. Let's see what's that. Some PDF sounds good. PDFs are always good, better than the usual HTMLs. And there should be some formula for that. And this is it. This is a sphere formula like we have two parameters, usually angles, and if those two parameters run between 0p, 0p, we would just get the sphere. So let's try to do that with our simple plane, and this for each loop. So first of all, each of the x and y coordinates now runs between minus 0.5 and plus 0.5. So let's introduce u, which is going to be equal bx plus 0.5, and v, which is going to be equal to, okay, I should probably rename this variable so you don't get messed up with this. So now we have two UVs, but those two UVs should be run between 0 and pi probably, right? Yeah, so it's gonna be 2 math p, and then this one just a math p, I think so. I think this is the right way. Let's try both of them, between 0 and math p. Now we could introduce the formula for each of the x, y, z coordinates. So we could do the x gonna be sine cosine, it's gonna be math sine u multiply, it's gonna be some math in this stream, right? But you need this math to create those weird surfaces. Math sine again, but from the v, y is gonna be equal same but cosine, and c is gonna be just the cosine. Yeah, there we go. I think that's right. So just copying this formula for the sphere. It's not that complicated, but I just open it up so you know that it's quite easy to find it online. So this one is a cosine, there are two sines, and there's a change in between sine and cosine. Sounds right. Let's see what we're gonna see on the screen. Okay, we have some errors already, which is cannot create property x on number 0, which is what? Oh, because it's not v, it's vector now. And now we have something quite weird, I should say. Not what I expected really. So this line, it actually goes, seems like it's on a sphere, but it's not what I expected to see. Because you know, this is the same coordinate. That's why. So now we see half a sphere. So we just morphed the plane into actually half a sphere. It's half because I think one of those should be multiplied by the 2p. So yeah, now we have the sphere coming out from the from the plane, right? And this is cool. Now we can morph the plane into something spheric. Okay, let's try to do that also. So we have those x, y, z, but we also have the original, right? I'm not sure we could use this formula now. So anyway, the principle I wanted to get here is that we can actually morph the plane from two parameters, like the x and y or u and v coordinates, into something bigger. This is actually not the good way to do that, because Three.js have a built-in function which is called free parametric buffer geometry, which does exactly that. One of the parameters of this parametric geometry constructor is a function. So for now it's parametric geometries Klein, I guess, and it generates some shape, and it takes usually two arguments and generates shape. So let's try to use the parametric geometry for that. So instead of doing this manually on each of the frames, I could do it with a built-in function for the Three.js. Let's do that now. I'm gonna copy this. Okay. I'm just gonna overwrite the old geometry. And here is gonna be some function, let's call it this plane function, 1, for example. And 25 is just utilization of the shape we are gonna be building in. So let's try to do this. For now it's gonna be just an error because because I don't have this plain function yet, but let's see. So this parametric function should be something documented here. I think it's easier to see it in examples. Let's get to them. There are some shapes, some example shapes and how to do them. And they are just trying to get some different functions and see how they turn up in the 3D. What I need here is to see like what exactly the parameters they're given to those functions. Let's see. I think we should see it like that. Yeah, now we should see the parametric geometries and parametric geometries. And there's this Klein function, which gets v, u, and a target. And in the end, I should set the target, but inside the function, I should just calculate each position of x, y, z vertices depending on the u and v. Okay, I can handle that. So let's do this u, v, and the target. I'm gonna copy parts so I don't have to write them down again. And here I should just calculate x, y, z. So for now, let's x gonna be equal to u, y gonna be equal to v, and z gonna be equal to 0. So this is just the plainest function you could imagine. So x and y gonna be linear changing depending on the u and v. Z is just 0 because it's just a plane in the z plane. And what else? I don't think I need this then. I'm not transferring any sizes there. So just the function should be good. Let's try it. Okay, it's not good yet because needs update. We don't need this anymore. So now we have a plane, and you could notice that it starts in a 0, 0 point because I made the parameters like this. So depending on the size, like I could just subtract 0.5 and it's going to be centered now. Yeah, simple as that. But the main difference, this geometry is now parametric. What we just did with this building those shapes manually in the request animation frame function, we could do this now with a built-in function with a 3JS. So it builds the geometry at the start and then you get just some different shapes. So now we could get this function. I already wrote that one here. I think I also need to u multiplied by the map 2, and then just like that. Oh, it's not a plane anymore actually. Fuck, I spoiled my plane function. It's gonna be a sphere function. So yeah, it's u, v, x, y, z, all this stuff. But it's quite easy to change it back because I wanna leave this function for the future purposes. So let's see, do we have any errors in JavaScript? No errors, so we could change the plane function with the sphere function now. And we will get the sphere. Well, I know there are much simpler ways to do a sphere with the 3JS, but just hold on a minute. We're just getting there. But this is actually a completely different way to build those shapes, because if you build it like that, with this kind of function, you could do a lot of different kind of shapes, like this one, for example. So you could do these weird kind of spheres. You could also multiply this all with something weird, like, I don't know, 0.5 plus 0.5 multiplied by math sine what? Math sine what? U multiplied by 10, whatever. And this is going to be some real top shit on my screen, but it's cool, you know, it's cool. Maybe if you change it to V, it's going to be something completely different. Yeah, you see? So we're getting some flower kind of shape now, and it's beautiful. And what's more beautiful about that one is that you can actually when 3JS builds this, yeah, why not? Why not wine at 10 a.m.? It's Sunday anyway, right? So when you build those when 3JS builds those shapes, it actually builds not only the positions of each of the vertices, but also what? Also it builds normals. So I could, you know, do the varying v normal, and I could v normal equals normal, and I could get that one now in a fragment shader, and let's just preview it. So it also builds UVs for us, VUV. Let's see, yeah, it's VUV. I'm gonna remove the wireframe attribute now, so it looks kind of better, but it looks kind of cool, right? It has some glitchy part here, obviously, where it's not equal to the 2p directly. So I was going to preview normals now, but we also have normals. And when we have normals, we actually can build the simplest kind of lightning. So I can do the float diff equals dot product of what? Dot product of some light position, which is going to be something like that, somewhere in a space, and the normal position. And I should normalize that probably to make it more realistic. And now I could just, what? Okay. I could just preview the simplest kind of lightning for my shape. It's something like that. Yeah, it's a weird shape, so the lighting is also kind of weird, and I think it's a bit glitchy. We could bring it back to the sphere so we could see the, bring it back to the normal sphere, like multiply this by 0. And we could see its sphere is a bit weird. Why is that? Why do I think it's that? Maybe I should, I think that means I fucked up at some point with my math. Okay, it's not gonna work like that. So the half a sphere is perfectly lighted now, right? But something is messed up with another half. And why is that? So they kinda turned around now. Where did I do this wrong? No fucking idea. I should probably remove this weird part that I was trying to distort my function with. Okay, still fucked up. Maybe I should go the other way around, counterclockwise. It's gonna be better this way. No, it's not getting better. It's kind of just turned around, so I think it's just some simple part in my math. But which one? Maybe this should be then minus. So any professional sphere drawing guys in the chat, where did I do this wrong? This is a sphere function which does what it is. It does. Maybe this one should be the other way around. Yeah, maybe, because I'm not even sure which one should go the 2p circle, and maybe if it does like this, it's gonna be okay. Okay, this is some weird stuff here. This one shouldn't be. Yeah, I guess we nailed that one. And this inconsistency is because it's actually a parametric geometry, so it's not real sphere. So it has some, you know, real small hole in the pole of the sphere. Yeah, so now we have the simplest kind of lighting we can introduce to this parametric surface, and now we could go into some more complicated stuff. So let's do that. So there is a number of different surfaces out there, and this is a wonderful resource. And you can see, like, this sounds weird in this year, right? So it's almost exactly 30 years ago when he wrote this part, which brings you like the history of the math. And there are some amazing studies of like what kind of shapes you can get with different kind of functions when you play with the sine and cosine and the coefficients and the, you know, exponential part of those. You could, you know, come up with some different kind of shapes like these real life shapes. Let's just try to play with it, and I'll try to get some weird shape from here. I think there was a weird one which looked roughly like 8th of March, and because it's 8th of March, and I can't help by congratulating the women all over the world with their rights. There's also a Klein bottle here, which you can just do with a parametric equation. Let's do this. So we have this formula, which is just sine, cosine, and depending on the u and v, and you could just let's do this one. Let's make it a Klein function, and the u and v should also go like v 0 to p, and u is the same one. Okay, I can do that. We can do that. So let's draw the Klein bottle with a parametric geometry. Yeah, it's 2, 2. I should replace this stuff a bit. And then there's multiplication here. It's multiplication again, and again, and again. And here as well, here as well. So at the first look, it might look like, what? It's just a random bunch of sine and cosine functions, but let's see. Klein function, what? We have some errors there, which is, yeah, I forgot the multiplication part here. Should be good now, yeah. No. A is not defined because, okay, we have some constants. When we're building the Klein geometry, we have some constants, which is A, and the A, okay, let's just, this is probably the size of the shape. So let's A equal 1. Yeah, now we see some weird shapes, and actually being lighted, well, almost correctly. Not really, but that's close. I think you should play with the, again, with the sides of these, like, should it run this way or should it be the other way around? Okay, it's not the right, maybe just something like this should do the job. So it depends on where those functions should run. Yeah, now we have the half of the shape, and that's what I was intending to do, because now we have 2 8 kind of shapes here. I can maybe preview for now, not the lightning part, because normals are being weird. Oh yeah, I actually know what's the reason for the normals. You were right, they're being flipped, and the only thing I need to do is just to take an absolute of this value. It should be, yeah, it's perfect now. But what I was intending to show you, it's those 2 8 shapes. So this is happy 8th of March to all the women. And we could see the UVs, they should be also quite good here. Yeah, I just forgot about the absolute part because normals were facing the other way around and we got the negative part. So they have the UVs, and by having UVs you can actually put some images on this surface, but that's not where we're heading now. What's beautiful about math is that by changing a couple of parameters you can actually come up with a lot of more different shapes. We actually drew this one now, not actual Klein bottle, because Klein bottle is this probably. We would need some conditionals. No, that's boring. Okay, so now we could proceed to the next shape, which is called Gray Klein's bottle. Is it a Klein or Klein? I don't know. I think in German it should be Klein. Okay, so now we have the U and the U, which is probably the typo. So U and V changing between the 2 and 4 P's, and we have this formula. Let's try to do that. Why not, right? Let's try to see. You probably could already guess what we're gonna see, but still. And it's gonna be Klein model, Klein function. Let's do this. At least we don't have to put the multiplication signs here. This is probably from some old drawing software. So it's all the math signs, and I have to multiply U to the 4 and this by the 2 U and V's, and I think I also have to have some constants like these ones because they're being used here in formula, and depending on those constants we should see different kind of shapes. Okay, and we should now replace it with our parametric geometry. And let's see. What? A has already been declared. Where? Oh, okay. I just forgot to delete that one. Still something is not right. P is not defined, which is good because I know why. And there we go. Now we just got the shape that you saw here. It's actually the same shape, just if you change those parameters, like, see, I could also make it more detailed because I used just the 30 vertices or 25 vertices there. Where was that? 25. Maybe I should use 100. It's gonna be much smoother than that. Yes, now we have this coolest shape you have ever seen, right? Well, hello Japan, probably. It's nice to see guys from Japan here. So it's a cool shape, but let's try to change the constants to see where it can bring us. Like, let's change the A, for example. It's gonna be a bit different now. If you change it to 1, it's gonna be smaller probably. Yeah. So you could get a lot of different, and it actually has the holes in there. You see, you can see through the shape. So let's make it like 1.5. Let's just play with it a bit and see what we could get just by changing those variables. This is another weird shape, but it's also a cool one, right? So let's make something real big and see where it goes. So we have a lot more circles now there. So probably M is for the circles. I don't need much of them. Let's make it 3. Let's make this one 10 and see. This already looks cool, right? We could also change back to the lightning model and see what? Yeah. And see some weird stuff. It's been a bit broken, probably because it is a bit broken. Okay, I think the most beautiful was something like this, and then you could change the first 2 parameters. Yeah. So now you could see this model. It looks kind of 3D. I just made a simplest kind of lightning, so you could see the shape and see that it's actually a 3D shape. So what you could do next? It's not actually what have been done here, and I guess you could see how you could proceed to this one now. Just you should change the material and change the lighting, the colors, and that's it. So what I want to do next, 2 things. First, I want to color it like I like it. I'm going to use the palettes from the Inico Keyless, and I can't stress enough how respect you should pay to this guy. You probably don't even know how much but I think one of the coolest guys in the graphic community. So he came up with those beautiful functions. I'm not sure if he, but maybe he just know them and he wrote the thorough article about those. I think it's done by him. So there are some palettes of colors that you can use. If you have some parameters running from 0 to 1, you could get some beautiful color gradient. Yeah, we're getting there. I'm just gonna color it and then we're gonna morph it and you'll see the cool stuff. Okay, so this formula here, I'm gonna just use it in my Vertex, not fragment shader. So I'm gonna use it. It's gonna return me a 3-dimensional vector. Let's use it AB multiplied by 2 multiplied by 3. This is as much as I know about this number. Brackets. That's it. So we have the color. Now we should just copy the, I like this one. Copy the parameters. So it's A, B, C, D. Okay, let's go. Boom, boom, boom. I just get it. I just get it. Yeah, it's okay. I just need a bit of wine before I proceed. So it looks simple, right? And t should be actually some number between 0 and 1. And what I want it to be, I want it to be my lightning model here. And fingers crossed, nothing works. That's good that nothing works. Dimension mismatch. Because, why? What? Because I put the 4 here everywhere. Obviously a typo. Okay, nothing changed because I didn't put the color in here. Let's put it in there. And now, yeah, you should see something cool, finally. Looks slick. And we just changed the simplest lighting model to the color gradient. It already looks cool. What could be done cooler about that? We actually have a time variable here, so we and the sine, it's a cosine function, but doesn't really matter. It's a periodic function, so we could just add time here. And this is getting out of hand now, right? It's getting way too cooler for this stream. Yeah, so now we have the periodic gradient running just like that, and it's already could be used on any of the award-winning websites. But that's not that's not what I want to do. Next thing we can do here is actually morph shapes, morph this shape into the other shape. So let's try to do that. To do that, there are a bunch of ways to do that actually, and you could do this inside of the shader. We could just introduce this formula which I used in the JavaScript, like this one. So we could build it inside the shader because we still have those U and V inside the Vertex shader, which is also a way to do that. But that's gonna waste lots of performance from the GPU. What we could do, we could save those two shapes in the attribute and then morph them one into another. That's gonna save us lots of performance. Where do I start with that? In the JavaScript. It always starts in the JavaScript. So let's make two geometries. Geometry 1 is going to be, let's make it sphere geometry of the same values, and let's see this geometry 1, what's actually in there. What's actually in that geometry? Why do I have two okay, because I have two console logs. So we have this parametric buffer geometry, it has the attributes, and there we go, it has a position. It's 30,000 vertices there. So now what I could do next, I could do this geometry. I don't remember this API. 3 buffer geometry, probably should be there in an example. Yeah, right. But if you don't keep them in the memory, they're going to be calculated on each frame again, and yeah, this is a waste of efforts, the GPU. This is the function I was looking for. So we could do this geometry attribute position 1 and buffer attribute vertices, and those vertices should be something from this geometry, and this is going to be attributes, if I remember correctly, position array. Should be right. Let's see in this object. It's attributes, position, array, yeah, and there we have all the values we need. So should be still working as before, right? It does. Maybe I should move camera a bit because I keep zooming out all the time. Okay, even further away. Like that. It's good now. Boom, boom, boom. Next, I was going to morph the target. Okay, so now I have the attribute. It should be accessible here. Attribute position 1. So instead of position, I could do position 1 now. And there we go. Now we have the shape sphere, but colored as a lightning model of this gray Klein bottle. And it already looks kind of cool in itself, right? It looks like a noise function or something like that. There's a bit of a singularity right here. It's cool. But that's not what I'm trying to do. So we have the time function here, and now I could do this. I could do the x3 final equals mix between position and position 1. And here it's going to be 0.5 plus 0.5 multiplied by math, not math anymore, by the sign from the time. And I should set the final here. So now we have this weird animation. Yeah. Okay, maybe I should slow down this a bit, because it's getting hard to look at my screen now. So we have a bit of a like inconsistency, but if you look at the correct angle for this shape, it looks cool. Maybe not. Okay, to do this a bit more smooth, this animation, this whole animation, you need to play a bit with those U and V angles so that both shapes are oriented the same way. And we can try. I'm just gonna spend a couple of minutes trying to figure out this way so it looks a bit more beautiful, you know, and see if I can. This indentation is fucked up. I'm not gonna try to fix it. I'm not perfectionist. Fuck that. I just can't look at this. It's much better now. Alrighty, so what I was going to do, I was going to change the orientation of the objects so they look kind of more cool when they morph into each other. So with sphere, I think when I changed all those parameters, I fucked up with those U and V's. So with the sphere function, sounds good to me. So maybe it's in the other function. Maybe just like that. Well, I think that's it. It's not going to be smoother than that. You just have to. Okay, now I have this inconsistency here. Yeah, you should just look at it at the correct angle, and then you get this cool kind of shape. Okay, what else we could do here? Actually, what the guys did, they introduced a couple of different shapes with different parameters, like here, you know, I was using those three parameters, but you could do something else, and then you're going to see something else now. I think this shape should also morph quite nicely into the real tor. If you just use the tor here somewhere. Okay, tor parametric function. I think I could just write it down. Let's try to draw a tor with parametric function. I almost remember it. So that two values, and both of those should probably run from 0 to 2p. And then should be somehow kind of like a sphere, but a bit different. And what's it gonna be? So this is this cosine. Okay. So one of those should be cosine, and I should just come up with these two values. Probably the other angle should be here, cos v, and then it should be math sine u multiplied by something dependent on the v, and to make it, well, probably should be different. That should be two different shapes. Let's see if it works out for us. Okay, now I should use this tor function, and instead of gray Klein, let's morph sphere into torus. So it's almost something broken. I think I should change also this one. Yeah, now it's tor. It's torus. And well, it looks kind of cool. So this is the torus morphing into the sphere. It looks quite interesting to me. And we still have this gradient, which is being the lightning converted to the pellet done by Aniko Kiles. So it's all already lovely. I don't know what else I could do here. Maybe I should stop right there. I should morph tor function now into the gray Klein. Yeah, okay, the tor is a bit flipped. So I should flip it too, maybe? Like something like that. Should rotate it a bit. I don't know. It's not going the right direction. Oh, because I'm multiplying this, and then I should, okay, that's why it didn't work in the first place before, because I was multiplying by some weird values. Now it's being rotated, and it's still not the correct angle. Maybe I should do the same with the U. This is about playing with geometries, you know. At this point, you could just try to come up with different numbers and see, well, I think it's good enough. You could also rotate the sphere so it fits a bit better to this morphing equation, and that's it. What you could do, again, you could, as already mentioned, let's see how much GPU we are using here. Stop. So it's not really much of the CPU used here, and the GPU, well, not much of the GPU either. So let's see how this would work if we would morph those shapes inside of the Vertex shader. Let's get to this, and then I would compare the two examples I mentioned before, because guys had kind of a dispute. I mean, guys and girls. Okay. How do I go about this? have this function, Klein function. So I'm gonna bring it back to the old plane. I'm gonna remove morphing from here. I'm gonna just use the position. Let's use the pos and equals position. And then, so we have some u and some v, which is just something multiplied 3. Then we have some constants. Alrighty, and now we have some values which have been calculated here. I have to remove now all this from here. I have to put dots here, semicolons, and now we could do just pos equals vec3 xyz. So if I don't do this, what's that gonna be? I guess I have some syntax errors there, which is property length undefined. What's that error about? Parametric geometry error, this plane function. Something is wrong here, which is, yeah, now it's shader of hue, line 65, plot V. Okay, some weird multiplication stuff I did there, which should probably remove this and multiply by uvx. Okay, now we have this simple plane geometry, and it has some UVs, and I just need to uncomment this line now, and we'll see the shape again. But now the calculations are being done inside the Vertex shader. So the same way I could do the sphere evacuation here, so I could do the same value. So pos now holds for the Klein. I could also just skip this part, and I can make the Klein like that. And let's pos gonna be equal mix between Klein and the sphere and this parameter. So I'm gonna do the same morphing, but inside the Vertex shader now. And what's it gonna be? I need to calculate the sphere now. I have the sphere somewhere here. Sphere. We have this, yeah, it's here. So there we go. And so it's gonna be once. I'll remove the weird JavaScript parts, floats, some lines, and then I'm gonna do, so I just made a sphere. Let's see if it actually works. It, okay, it doesn't, because I forgot to took once here, and now we have an errors. Why is we have those errors? Why don't we see anything here? Because I forgot to multiply these parts. Yeah, now we have the sphere, and now we could do the last part and just make it morph. So now the sphere is morphing into the plane. Because why? Because it's not about this, it's about post variable. It's not a shape. This beautiful shape is morphing into the sphere. That's good. And we could just see how much performance we are wasting here. Should probably be visible now. Well, it turns out it's not much of a performance waste. Maybe the GPUs are that fast and I don't have actually much of the vertices here. If I put a lot more, maybe I would see the performance drop. But actually, when I tried to do that before the stream, I actually saw a huge performance drop. Maybe it's being cached, the calculations are being cached or something like that. Let's see it again. So it should be performance drop, but for whatever reason, it's not visible in the tools. Maybe because the graphics processor is being hot now, but it still can handle those calculations. But it's getting hotter and the fans being turned on, but it still can handle those easily because it's just 100 by 100. But we could make those thousands. Like, where do we have this hundreds? We could turn them into the thousands just to explode my key. And it still works great. Okay, so the GPUs are good now. That's the answer. And the last thing I wanted to do here, I'm gonna leave you with a beautiful part of this whole animation. I'm gonna do the final, which is gonna be just the position 1 maybe. Yeah, and I'm gonna I didn't want the plane, just wanted that to be a Klein function. Yeah, with this beautiful version. And the last thing I wanted to do, I want to see how different are those two versions. So if we see in this code, Misaki Nakano, a couple of years ago, she used this formula for morphing the shapes. She used like this one, like the same that I just did. So this is the final shape, and these are two shapes that we are making in a shader. And this is a shape ratio, which kind of calculates this function, like how fast it should morph in one into another. And there are two formulas, the same ones I just showed you. This is a great Klein bottle, and this is the sphere function. And they're being morphed between one another. And there was another side in a dispute, this one. And let's see how they did this animation. So I could go into the shader and see their function. Well, those two shapes have the different names. Shape 1, shape 2, that Klein bottle, because it's data, not because it's that Klein bottle. And some organicity, but what gets me here is this 1.5 parameter, because it's actually the same that Misaki Nakano used, which kind of looks too familiar to the formula she used in her shader. All the variables are renamed, but you know, this coefficient being the same and that one. So I guess the guys were inspired by that code some years ago, but they built on top of it a lot more. They built the shading, they built some different lighting model, and it turns out the calculating in the shader all those parameters again on each frame is not much of a problem performance wise. It's more like a problem for the fan wise, because all the fans are being turned on and my PC now is getting hotter and hotter again. So yeah, the code looks kind of similar to me. I don't know, but maybe the guys just came up with the same kind of coefficient and functions. And you know, everything on CodePen, you know, everybody steals something from the CodePen in a good way. You're just sharing the knowledge. Maybe they should just give a bit of a credit to her. It would be it. So okay, I'm not here to decide and judge people's actions. I was just trying to see how much similar are they, and I was trying to make this weird shape, this beautiful shape, which is called gray Klein bottle. And you can read a lot more about that one on the Paul Pork website, and there are a lot more different kind of shapes that you can come up with. Even this one is a beautiful one, and the Möbius strip, and lots of shapes here. And if you could go to his website, actually had the whole section dedicated to different kind of geometries that you can draw with all the parameters. So this is actually a 3D truche. Oh, how cool is that? It's 2006, by the way. And this looks beautiful. Maybe I would make it in one of the next streams. And they also have the reflections of itself. I kind of want to do that. So you could play with those geometries, you could try to do that. You can also support me on my Patreon if you like the stuff that I do. It really inspires me to do more. And well, thank you guys for being with me this morning. I'd like to hear your feedback. Happy 8th of March to all the guys, to all the girls, to all the girls and women, and especially to all the loved ones. I mean, the closest to us. Okay, whatever. Everybody. Happy 8th of March. And have a nice day, guys. I was glad to see you. See you next stream.